Road to Olympiad.
Welcome to RTO. Consider the following problem. A positive integer n is strong if every divisor of n is 2 less than a prime. Find the unique strong number with the largest number of divisor. For instance, 3 is strong because its divisors, 1 and 3, are both 2 less than prime numbers. Whereas 6 is not strong because one of its divisor, which is 2, is not 2 less than a prime number. Again, we are not only required to find the strong number, we need to make sure that this is the one with the largest number of divisor. Pause the video if you like to give this problem a try, and when you are ready, keep watching to learn how to solve it. To solve this problem, we start by noticing that the prime factor of n must be either 3 or leave a remainder of 2 when divided by 3. Otherwise, that factor will be 2 less than a multiple of 3, which is not a prime. Notice also that n cannot be an even number. This is because 2 is 2 less than 4, which is not a prime number. Also, n cannot have 2 prime factors, both with remainder 2 when divided by 3. We will prove this as follows. Assume that p and q are the 2 distinct prime factors of n with remainder 2 when divided by 3. Then, the product pq must also be a factor of n. This implies that pq plus 2 must be a prime number. However, by the condition both p and q leave remainder 2 when divided by 3, we have p is equal to 2 mod 3 as well as q is equal to 2 mod 3. This implies that pq must be equal to 1 mod 3, or in other words, pq plus 2 is equal to 0 mod 3. But then, this is impossible for pq plus 2 to be a prime unless it is equal to 3. But if pq plus 2 is equal to 3, then both p and q must be equal to 1, which is a contradiction as 1 is not a prime number. With the same argument, we can show that if p is a prime factor of n that leave a remainder 2 when divided by 3, then p squared cannot be a factor of n as well. Therefore, it leaves us with n is either equal to a power of 3 or a power of 3 times a prime number p with remainder 2 when divided by 3. It can be easily checked that for the case of n is a power of 3, it is maximal when n is equal to 3 to the power of 4. And this n has 5 divisors. For the case of n is a power of 3 times a prime number, if the prime number is 5, we can also easily check that 3 to the power of 3 times 5 is the maximum. This n has 8 divisors, which is more than the previous one. We claim that if the prime number is more than 5, we will have less divisor. In fact, in that case, the power of 3 will be less than 3. This is because if k, the power of 3, is greater than or equal to 3, we have p, 3p, 3 square p, and 3 cube p are all the factor of n. This implies that all these following numbers must be all prime numbers. However, this can only happen if p is equal to 5 mod 5. Otherwise, one of the above will be a multiple of 5. This is not a coincidence. This happened because 3 is a primitive root modulo 5, and so all non-zero residue appear as a coefficients. So, if p is greater than 5, the strong number we obtain can only have a maximum of 2 times 3, which is equal to 6 divisor. Therefore, the strong number that we are looking for is 3 to the power of 3 times 5, which is equal to 135, which have a unique 8 divisors. And this marks the end of our solution. Post in the comment below if you have any thought on the video, and if you haven't subscribed yet, consider subscribing. This will really help us out. Anyway, see you in the next video. Thank you.